Awesome. Well, first of all, thank you for having me. It's really an honor to be just part of the conference. I really wanted to kind of focus a little bit on a little bit of the present and the future as comes to AI. By now, everyone is very familiar with using generative AI and large language models for testing, but I think we can go beyond testing, and I think that we're already seeing like a paradigm shift. So, what I want to do is kind of just level set a little bit of the journey that we are so far and summarize the current state, and then talk a little bit about the future, especially in a way where practitioners in testing really can provide value. And so I like to talk about the future from time to time. It's very important to stay where you're at and think about kind of where you're going. Even imagine that future is something that I like to adopt, called right to left thinking, if you want to look that up, where you imagine yourself in the future. And so, actually, I want to go back to the future because back in 2015, I was applying this concept of right to left thinking, thinking like, hey, where are we going to be as an industry in a few years? And at that time, I was thinking like, hey, testing is really very dissected, number one, and it's very focused on manual testing. Um, and when I say manual testing, of course, like there is the traditional idea of human present testing or exploratory testing. But even when we thought about automation or test automation, we would think about creating these test scripts, and it was very much a manual process. And at that time, I met a gentleman named Jason Arbin at a conference, and Jason and I were working on and thinking of the same problem. And that was that, like, hey, there's got to be a better way to do this. A grand vision of testing where we can actually have true automation, right? A lights out philosophy where you could turn off the lights of a factory, comes from the manufacturing days, and the robots would be so automated that they would continue working without, needing any light. Literally applying that philosophy to testing, where we would have testing with little or no human intervention. And so that was the dream back then. And we actually formulated this dream in the terms of a space, which we coined AI for software testing, where we were talking about AI driven test automation. So building tools using AI that could be more automated. Also, intersecting with that was the idea of testing AI systems, because you can't really build something with AI in it without thinking about the quality concerns. And then, because AI was so very dynamic, thinking about how do we actually test these systems and design them with testing as a part of that runtime. And at that time, I was very fortunate to do some publishing with O'Reilly. Jason and I teamed up. I joined his company, Test.ai, and we worked on a lot of cool projects. And during that journey at Test.ai, I thought it was very important to actually document a lot of what we had been innovating on as we went along in this space, right? And so I published this technical report that really talked about real world AI in software testing. So we were using AI for things like automating web and UI applications. Because AI was so very reusable, we could actually use it to test entire sets and suites of applications in the app stores. So we could apply it on a very global scale. There was also unique things that we could do with computer vision, because, as you know, things like testing video games is very challenging. Probably one of the hardest testing problems out there because of the visual and dynamic nature of these things. And we were using reinforcement learning and some other techniques to test games, combining that with computer vision. And then, last but not least, looking at things like video quality. So a lot of hard problems that, like, we could start using AI to actually make a dent in these things. And we could see like that AI was going to start to consume our space. And again, it was good that we wrote this down because now we're actually seeing it. And we were at that time thinking about the future, predicting that there would be this kind of full stack takeover of AI driven testing, where we were using AI driven testing for core concerns, like UI testing, API testing, and unit testing. But also, then we were going to start to see AI being used for security testing, for performance and UI design, and so on and so forth. And of course, with all of that, because we are indeed testing nerds, it was a lot about still recognizing that we would still need testing to be a core part of the entire equation, right? So self-testing was going to be a part of these adaptive AI and machine learning systems, because there was no way that these systems could actually um, be deployed out there if there weren't checks and balances. And maybe at first you might need humans involved in that loop, but maybe over time, as reinforcement learning, as the humans were feeding these systems, they would take over more and more and be able to test themselves. So again, that was a nice flashback to the future back from 2015. Now, nearly a decade later, we're in 2024, and we're actually living in the world of generative AI. And I don't think we could have seen like the transformation happen any other way. It just felt like it was gradual because we had these models available, and even at Test AI, we were using GPT 3. But as stuff kind of happens gradually, and then suddenly, all of a sudden, we saw, hey, AI is actually able to take over a lot of generative tasks, right? So creating audio, images, videos, and doing so with little or no human intervention. So we've been able to use AI to do things like generate photos. These are all people that don't actually exist, all generated using AI. Um, I had some fun last year at different conferences, actually taking the audience through some quizzes as to whether something was real or fake, including these faces, but also generating things like artwork, right? So AI is actually able to do a pretty good job generating and mimicking, what would be kind of human artistry in different levels. Of course, things like paintings like this, but also music. Um, it's interesting because as you see AI mimicking and playing these imitation games, you start to realize that it's becoming more and more difficult for us to distinguish what is real from what is fake. Um, and it's not necessarily always a bad thing, but it does make us think about the security concerns there. And of course, our favorite chatbot, ChatGPT. To me, I always tell people that ChatGPT did one huge thing for this space. Um, and yes, of course, solving NLP problems is something that is a challenging problem, something that's a very interesting problem. But we had NLP tools. But this really put NLP and very believable NLP in everyone's hands. So I always say that this technology made AI very believable, right? It was now very visible to everyone. As one of the biggest challenges that I had throughout my journey was when we were showing people AI systems doing incredible things, they always wanted to kind of see the AI and be able to talk with it or interact with it. And we just couldn't do that, right? We were building a proprietary platform. We would do our best to visualize it, but ChatGPT literally put it all in, everyone's fingers, right? Um, so of course, we have now these language models that can do a lot, um, and we're using them. Particularly, we're using them in the software testing space and automation space in what is kind of typically referred to as Gen AI assisted software testing. And so when I talk about this, I'm talking about a couple of different use cases that have become kind of mainstream. The first one being using AI to do test case design and creation, right? So things like analyzing requirements and generating tests to cover the application, user acceptance testing, maybe looking at the source code itself and the APIs. But whatever are those documented tests that need to be designed to cover boundaries and equivalence classes, we can use AI to support that effort. And now with multimodal systems, we can actually use it to do things like analyzing state machine diagrams and decision tables, more visual aspects of it. And so test cases are one thing, but we're also in the implementation. So thinking about unit testing or integration testing at the lower levels, you can leverage this to actually generate entire scripts for UI testing. Also do things like analyze those paths through the code and generate specific tests to traverse different paths. It's actually quite impressive once you start putting this technology all together, because you know that all the way from test case design through to the implementation of a script can now be automated, and it's not just this kind of manual kind of focus anymore, but truly automated testing. Test planning, right? Thinking about prioritizing and documenting the testing process, which is also very challenging and very time consuming. It's now helping people do that. And then being able to help maintain and manage like what is a very complex set of artifacts and relationships across the life cycle. So starting to think about how do we keep our test cases up to date, how do we reduce redundancy and kind of help with maintenance and that sort of stuff. And then one thing that it's good at, as we mentioned, is mimicking, different processes. So actually, a very hard and challenging problem over the years has been how do we get good test data that is very realistic and helps to match up with production systems, right? That is usually where, even though we do our best to test in the lab, we release it into the wild, and typically with very complex data relationships, it becomes very easy to see that we've missed certain things, right? Well, doing synthetic test data generation by actually analyzing the real world relationships in real data is where also this technology is starting to thrive. And last but not least, actual test execution. We could always kick off things automatically, but really when it comes to using a lot of the predictive analytics and different aspects of even generative AI to help reason or summarize results and help humans to really digest what is a large volume of either failures or defects, this technology really moves the needle. So this is where we're at. We're seeing this technology being applied in testing. And it's great because, quite frankly, testing has lacked a lot in the department of innovation, right? And automation, especially. We kind of feel like only certain things could be automated. And now we're seeing that this is not the case. There's more that can be automated using AI. And where I think all of this is just going is we are basically looking at generative AI across the board, not just in testing, but across every aspect of our lives. And particularly in the context of work, trying to figure out how can we use it to make us more productive. And when I say more productive, it is really not just about moving faster, right? Because you can move fast and actually make a lot of mistakes or have poor quality output, and overall you're moving slower. So productivity, yes, it has some element of throughput or the quantity of things that you're producing, but it also has an aspect of quality, right? Are you actually producing excellent work? And then there's a third element of efficiency. And it's really the intersection of these three things that I think is driving a lot of generative AI adoption in the workplace, and in particular in software engineering. And if you're anything like me, you like to think as a tester very holistically, right? So it's across the entire life cycle. We know we have everything from requirements all the way to deployment. And we can typically start to think about the different types of tools that can assist us with requirements engineering and user design, and actually applying this to system design or software architecture, implementation of the code. Of course, we started a lot with Copilot and so on and so forth. Testing, as we just mentioned, but also deployment and so on. And so we're in this state now where we are completely immersed in looking at how this technology can be integrated and interwoven into software development life cycles, and into entire organizations, including their processes, their practices, and like a lot of even their culture of how we do things. And an important thing to kind of mention here is that when you start moving towards this type of technology, um, because it does so much, we have to be very grounded and rooted in a solid practice of engineering excellence. So at the bottom level here, where it talks about engineering excellence and agile practices, things like shifting left and quality engineering, that is the foundation that we really have to build upon. And this will become important later on when I start talking about the trajectory of where we're going. But just remember that we can't not have a good baseline or not have good practices in place. Otherwise, we're going to actually defeat the purpose of using technology like this on top of what we're doing, and we're just going to go nowhere fast, right? Um, but I wanted to just step through for the practitioners and those who like to be hands-on exactly what tools and so on we're dealing with today across this life cycle. Of course, there's tools for generating user stories and acceptance criteria, things like UI mockups. It's actually very impressive what we can do now. I'll show you kind of some snippets from some of these tools. Um, at EPAM and TestIO, we contribute a lot to the open source community. So we actually built a tool called AI Genie, and it's part of Jira and available in the Atlassian marketplace. And the reason I bring this up is twofold. Number one, yes, like we can use this technology to automate a lot of things, including here generating acceptance criteria from natural language prompts, even generating sequence diagrams. But the other thing, and the reason that I choose this first, is because one of the things that we're seeing is that you want to bring this AI technology, this generative AI technology, to people in the environments and in the tools that they're actually using on a day-to-day basis, right? And so this is kind of the philosophy, not to have you context switch, but you're going to see AI being more and more integrated, not just this kind of standalone, let's go to a chat GPT window, but integrated and embedded in your everyday tools. And we're seeing it already. And this is kind of like the philosophy that we brought here with this as well. Let's put it in there. So you can actually configure your own LLM with this. It's completely free, and just go and use it, right? All right. So that's requirements engineering. Of course, hand in hand with that is UI design and mockups. Wizard is a commercial tool. I'm not affiliated with them, but I think it's really cool. Something very simple like a prompt, like give me a weather app for the planet Mars, and click generate. And all of a sudden, like all of this magic happens where your app has been designed with, fake images that are relevant with good layouts. And then you can go and edit all of those wireframes and so on and so forth, and even take it on to the next step. So that auto designer is pretty cool to see actually in action. It kind of seems like a little bit of a dream when you think about this stuff, that you could just, with a few prompts, get so much output. But it's a very good use of AI in the requirements realm and design realm. Of course, there's more than UI design. There's actual software design, so architecture models. So thinking of sequence diagrams or any kind of cloud deployment diagrams, like you can, again, apply this technology to those aspects of creating your software solution. And there's a cool tool for this as well that I found out there. It's not free, but it's not that much to get a couple tokens to be able to play around with. I guess some are actually free. But Diagram GPT, literally you can enter a prompt here, actually put in, I wanted to create a cloud architecture for a social media application, and watch it start to do the magic. And actually specific to the technologies that I was interested in here, AWS, and so S3 for storage and EC2 for compute, and just watch it build out the architecture. And I mean, I wish I had this stuff when I was actually in college doing sequence diagrams by hand, but maybe I wouldn't have learned as much software engineering if I had these tools. But I know I would have definitely saved a lot of time, right? So also important to know that these are tools that are out there and are available, that you can use. And it actually infers, actually is cool. It actually infers what type of diagram. If you don't know what type of diagram you need, you can just put in what you're trying to achieve, and it might auto detect and give you an appropriate diagram. So Check that out. That's eraser.io/diagram GPT. All right. Of course, there's been, since the inception of these things, a lot of work on co-pilots that sit within the IDE. GitHub Copilot is the most popular one. And so now we're not talking just about IntelliSense, of course. We're talking about generating entire code blocks, right? Which itself raises a lot of questions and concerns. But it's no doubt that it can definitely help to accelerate software development. Similarly, also, this is another tool that we have implemented at EPAM, but in the software testing space. And of course, Copilot has some software testing features. But what we found was that it was kind of lacking when it came to really the types of features that we would want embedded in an IDE for testing. And so we built the Alita platform. Here's just an example where we have our prompts living again within the IDE. We can, have those prompts do things like pull from the IDE what language the project is in and say, hey, we want you to act as a developer of this particular project language, in this case, Java, understand the code, and generate unit tests following best practices, right? And watch it do its generation on the right-hand side. It's pretty cool. So again, bringing this technology, if you're a test automation engineer, you need that code within the IDE. You don't need it somewhere else. And so Alita started off as kind of this solution to this particular problem. We'll see as we talk about the future how this is actually transforming itself into like a collaboration platform. And last but not least, AI in the CI/CD platform. So thinking about DevOps, thinking about how generative AI can help. Of course, we can use AI to generate things like Terraform code, do our error processing via pull requests, and even do fixes and suggestions, right? So you can embed it there. Clearly, you can embed it in the application code itself with all the things that we just mentioned, but have that really be integrated into the pipeline and as part of the quality gates, right? So go or no go. And this is where, like, for me, I was starting to realize that even though we kind of talk about testing, and even as I think about this particular example where AI is being embedded in the delivery of the project, and that quality and the quality gates are a key part of this, that we were actually moving towards this idea that even though we were talking about productivity, that quality was actually equal to productivity. Because as much as we want to use this to accelerate, if we don't have those checks and balances, we can't do it. And it's funny because I spent a large part of my career at Ultimate Software, and one of the mantras of our quality organization was this Q equals P. Actually, it was broader than just a quality organization. Our CTO, first time I heard it, our CTO actually presented it at a new hire conference. And the idea was that, if you have an equation like this, and quality on one side and productivity on the other with an equal, that any deviation in quality, if quality goes up, then productivity goes up. Similarly, if quality goes down, productivity goes down on the other side. And so they were kind of one of the same. And with AI, I actually see us automating quality engineering. So as we think about the life cycle, and as we think about needing checks and balances throughout the life cycle, what is quality engineering, right? Is the idea of building the product right as part of engineering process, so you can build quality into the product rather than testing it out at the end. And of course, validation and verification at every stage is a part of that, but it is a lot more efficient than just letting stuff go through and then trying to do a waterfall type of test. So this AI thing is going beyond testing, and it's great that it's going beyond testing, but itself it actually raises a number of new challenges, right? We have to be able to navigate this road to adopt AI in our organizations. The first thing that comes to everyone's mind is security and intellectual property. As I deal with consulting engagements, this is the first aspect of it that we have to cross. If you can't cross the security stuff and the IP stuff, you actually can't move forward. But there's good news there. We also need to make sure that people are prepared and equipped to use these tools, right? Because it is not just as simple as free form, just asking the LLM a question and thinking that you're always going to get a good result. Sometimes the right question can yield the wrong result, but of course the wrong question will always yield the wrong answer. And so that is a key part of that navigation. There's also obviously the tools generating all of this AI generated content that looks very correct to the untrained eye, but it can hallucinate, right? So these things can actually be wrong. And of course, measuring productivity or quality, if you Q equals P it, is actually very non-trivial. And so while people are looking to try to get gains from using this technology to make things better, we have to make sure that we're even approaching that problem really, really well. And so I think like my focus here today is really about answering this question, right? Like how can we actually go about integrating generative AI for software productivity into the life cycle and throughout the whole life cycle, not just a part of it, and actually, in essence, automate quality engineering and automate the quality of the product. So there's a couple things that are a part of that, right? The first thing is we need secure and enterprise-ready access to AI, and this is of essence. And the good news is that it is possible. You don't have to use the public API of OpenAI to do what you're doing. You have enterprise-ready alternatives like Azure's infrastructure for that. Of course, Google has their own thing. At EPAM, like we have focused a lot on making sure that there's a secure proxy to all of our LLMs. The portal that we have and the initiative is all called AI Dial. But AI Dial is really that proxy to say, hey, we want to have all these models available. Claude, GPT-4, Gemini. We want to be able to build off of all of these, but we need all of this stuff to stay within EPAM's walls and not to be anything that's a risk. So that is important, and DAL gives us that as an initiative. And so I'm sure your organizations are already thinking about how to do this. And the main point is that you really need to make sure you solve that problem first. The other thing is that, as I mentioned before, we're realizing that AI for software productivity is also a very cultural thing within the organization. People need these tools, but they also need to be able to collaborate, right? And so Alita, as I mentioned to you earlier, which started off focusing on software testing, has also shifted out towards more tasks and actually a broader thing. Like, how do we enable these prompts that we have, regardless of what they're trying to achieve, to be shared across the organization, right? And for people to be able to collaborate on these things, reuse them across projects, and so on and so forth. And then down the line, how can we actually use these to actually build more automated systems that we'll see and we'll talk about that go beyond just the co-piloting, right? So that's important to have this kind of secure, collaborative, enterprise-ready AI at your fingertips to solve problems related to the team really using this technology correctly. You need to make sure that people understand prompt engineering. And I think that sometimes we start to dismiss the importance of this because with AI, there's a lot of hype. And so in the beginning, it was just like, oh, the future of anything is that you'll just need to know prompting, and prompt engineering was going to be this big career. A lot of that is hype, but a lot of that only distracts from the fact that you still need to be able to learn these things and interact correctly with these models to get the most out of them, right? And I started thinking about that and how I could contribute. Of course, I give a lot of trainings, and I had created a prompt engineering course that I taught. But I thought I need to make this bigger. I need to make sure that we get this right and disseminate this across the world on a global scale. And I can't do that myself. I'm just this little kid from Barbados that ended up in this space. Um, but so I teamed up with Artificial Intelligence United and Brightest to actually create this certification specifically for the testing community, right? So how to actually use these models to assist testing really, really well. And I'm seeing that it's becoming bigger and broader than that. So we're continuing on that path. And this is not a plug for that. This is more um, you need these skills, right? And there's a whole dispute in the industry about certifications or not certifications. Um, I think what matters is that you get the knowledge, and for some people, getting a certification helps them formalize that, and that's great. For me, I wanted to train trainers, so I wanted to train people who are going to do this, so that we could scale this across the board, and we could have this translated into multiple languages and have it just disseminated across. Um, so yeah, feel free to reach out to Brightest. Uh, some of you may know Kyle from Brightest. I always say he's the brightest person I know. If you're interested in that, but this is kind of like where I think the world is going to go, and you're going to see that we need these skills. It's not going to become necessarily your career, but you will need these skills in a lot of what you do. And I've been learning more than anything. So I teach this course with Raul Verma, and I think every time we do it, every time we train the trainers, we learn so much about AI and machine learning and testing together. It's amazing. So just please make sure that you do not ignore prompt engineering as an important skill. And last but not least is what I mentioned before, is that you have to be able to test these systems. So um, if we're going to trust AI, we have to be able to make sure that we understand quite a bit of what's going on, and that we have good practices in place for actually validating these systems. So I wrote a series of articles like earlier this year on AI shifting left and actually still testing on the right. And it's really about having this very holistic view of how AI systems are built and deployed, and therefore how they need to be tested. So it usually takes a village, right? There's all these different roles involved, whether it be machine learning engineers, data science teams, there's cybersecurity software engineers, there's an end user. And if we want to have, this kind of continuous testing, we first need to have testing up front with good practices. Should this actually even be solved using AI? Um, and once you figure that out, yes, it needs AI. Then what about the data? What data has been used, right? How do we actually influence the outcome or measure the results? Like, what metrics do we put into place to actually know if the AI system is behaving well? How is the design of it? Does it use retrieval augmented generation if it's a generative AI system? And how can you use that to help you inform the testing effort? And then recognizing that even as you pay attention to how it has been specified and designed, that you still need testing to happen after the system has been deployed, because these systems are so very dynamic, because they give different results when you ask the same question. They're also very non-deterministic. You need testing in the wild. There's adaptive AI and there's generative AI, and both of these types of systems really have the capacity for new things to happen at runtime. And so a big part of the education there is thinking about the fact that, yes, there's a user experience, there's what you see and how you interact with the model, but there's a whole heap of things beneath that iceberg. So I coined what I call the testing iceberg for testing AI infused applications. And it basically says, like, hey, you need to look at things like the content integrity, right? How accurate are the results and coherent? You need to think about engagement, right? So if this is a conversational model, is it keeping your interests, right? Is it fluent? Do you have good contextual understanding of whatever the user is asking? And so the model is actually coming back and giving you interesting things for the next stages. Responsibility and fairness is a huge thing, as well as obviously like safety and security as part of that. And then people are using these models to achieve some task, right? As we saw even in the engineering process, if you're creating test cases or doing test planning, how useful is this tool for what you want to do? How concise are the results, or are they very verbose and it distracts from it? And so um, the kind of note here is that like we need to have trusted AI, and for us to get towards a place where we have AI that we can trust, we really need to make sure that we can test it. And so to test it, you have to be able to control it. You have to be able to observe what is going on. And in this case with AI, you actually need to have it to be able to explain why it came to certain conclusions. And so there's a whole field out there of what is called explainable AI, where you're making sure that you build AI in a way where the models can actually give a reason for why they came to a particular conclusion, because that is the way that we're going to be able to actually debug and figure out how do we make them better, right? If we can't look at that information, if it's not observable and not explainable, then we can't make it better. There needs to be explainable data. There needs to be explainable predictions. Why did it come to a particular answer? And then the algorithms themselves, all the different layers that they're going through, also need to contribute to that. And so all of this to say that we're heading in a new direction. Of course, you would have seen some announcements like Devon AI, and now I saw one advertisement for Co-Tester. This is by no means an endorsement of any of these things, but what we're seeing is that we're going towards like true autonomy, or trying to get there, right? Can we actually have fully autonomous software development, right? Or fully autonomous testing? And sometimes it seems like, okay, this could be a dream and or a nightmare, depending on if we think we're trying to replace humans. But I actually see a big future that motivated this talk of the SDLC with AI. And the cool thing is I work with some really great people that are also embodying that vision. Adam Marbach and Artem Ruzimenko, like in thinking about where we're going, um, came up with this set of waves. And so, and I myself have also thought like, hey, we started with IntelliSense and we have these co-pilots, and now we're introducing leveraging agents as assistants to us. But there will come a point where we see the agents are the ones who are primarily doing the tasks, and we trust them if we get there. And maybe they are fully autonomous in wave 4 and by themselves. And then the scary part is where do they go from there? Like if they become super intelligent, right, or they become autopoietic, then what are we doing as humans, right? And that opens up a big set of questions. But really, um, my charge here is to understand that like we're going, and right now we're here with these agents as assistants still, and we haven't necessarily reached this full autonomy. Um, but I think every day, I think we look at the news and we see another advancement that brings us closer and closer and closer. So as a testing community, we can't just sit back and hope that it'll get better, right? Uh, people are going to use AI for good, and people are going to use AI for bad, and we need to make sure that we're contributing overall to making AI better, right? So some sort of ethics framework and thinking about responsible AI. How do we govern these AI systems? How can we make them explainable? How can we make sure that they're very transparent in how they behave? I follow a couple of folks that have been really instrumental in this space, and I think this is going to be the future of the software tester, actually. Um, And it's really important to me because I have two small children, and I always think about them growing up in this new world of AI. And they're already interacting with AI on a daily basis in my home. And so it's really important for us to make sure that we come together. So, as much as this is a vision beyond testing, this actually is still a vision about testing and the need to test these systems really well, because it's not just about automation, right? It is about the safety and security of our people. So, hopefully, you enjoyed that, and thank you very much.